Right, our final type of problem is more an application problem that deals with trigonometry. Suppose you stand 53 feet from a wind farm turbine and your angle of elevation to the hub of the turbine is 56.5 and your eye level is 5.5 feet above the ground, and you're asked how tall is the turbine from the ground to its hub. So the first thing we need to talk about is this angle of elevation, because we have two things that we're going to be looking at in problems that are similar to this, is the idea of angle of elevation. So you'll see that term. You'll also see angle of depression. And in this problem, we're only talking about the angle of elevation. So I'll show you how to do that first. And even though it doesn't come into play in this problem, I also want to talk about the angle of depression so that when you see that, you know what is happening. So the angle of elevation simply tells you at what angle would you have to look up to see the top of the object. And I highly recommend with problems of this sort drawing a picture, and it doesn't have to be beautiful. You saw my exemplary drawing of the tree earlier, so understand that your drawings just have to be approximate. So let's say that there is a wind turbine and you are standing there looking up at this turbine, and you're looking at the hub of it, which is where all those come together, where all the equipment is for generating the electricity from it. And we are told that we're 53 feet away. So if I draw out a triangle this way, I know that distance is 53 feet. And we are asked how tall the turbine is from the ground to its hub. So we want to know this distance right here. So let's talk about how we figure this out, and it all hinges on this angle of elevation. So angle of elevation, again, is how or what angle you have to look up to be looking at that object. So the angle of elevation is right here, and we know that that is 56.5 degrees. So if you look, this is a pretty classic trig problem here for how tall is an object. We know our angle of elevation, we know our distance from there, and we want to know this distance here, which in terms of this triangle is the opposite side. Let me just label that. So there's the opposite side. This would be the adjacent side. So we're looking for a trig function here that includes the angle, the adjacent, and the opposite. So tangent is our man. So we say the tangent of 56.5 is going to be equal to our opposite side, which we don't know, but we're very interested in knowing, and our adjacent side, which is 53. Now we just need to solve that for x. In order to solve this, when you have a fraction on one side, you always want to multiply by the denominator of that fraction to eliminate it. So we multiply both sides by 53. So 53 times the tangent of 56.5 is going to be equal to x, and this is why on the 6th day God invented the TI-84. So we say 53 times the tangent of 56.5, and the answer we get is 80.07. So x is 80.07 feet. Now, be very careful, because you're tempted here to say, oh good, that's my answer. But we want to know how far it is from the ground. What we have found is how far it is from your eyes to the top of that. And your eye level is 5.5 feet above the ground, which means this distance right here is 5.5 feet. And this distance here is 80.07 feet. So to find the total distance, I have to take this and add it to that. So 80.07 plus 5.5 is going to equal 85.57 feet. And so that would be the approximate height above the ground. So again, the key to this is knowing that the angle of elevation is how far upward, angle-wise, you have to look at the object. And once you've realized that, what you've set up is a trig problem where you're finding the height of an object. So let's talk about the difference between that and the angle of depression. Suppose we have a cliff face and we're looking at a ship. So pretend with me that that's something that's not terrible. And we have somebody on the bow of the ship and somebody on the edge of this cliff. One is safer than the other. All right, so they're looking at each other, right into each other's eyes, as passionately as you can from a boat to a cliff. We've set up two angles here that are of interest. We already know this angle here is going to be our angle of elevation. So let me just label that. So that's angle of elevation, how far you're looking up in order to see this. Now the other one is for this person. When you're looking down, imagine that this line describes how this person would be looking straight out, but they're looking down. This angle is the angle of depression. That is how far they are looking down in order to see whatever object they're looking down upon. And notice that just as you can set up a right triangle with your angle of elevation, you can also set up a right triangle with your angle of depression, and the opposite side is still going to be the height. So these two things are very, very related in that you can use them the exact same way to solve a problem. The thing is you have to realize what that means.